Why is benzene less reactive than cyclohexene? There's still 6 carbons, but there's 1 single double bond in cyclohexene and there are 3 double bonds, or at least the structure implies it, in benzene. The reason is that benzene has what we call resonance structures. When you have a 6-membered ring and alternating double bonds, how do you know which carbons those double bonds are alternating between? If I drew you this hexagon with the other bonds having been double bonded, how do you know that that's not the case? Well, you don't, and in fact, these electrons are what's called delocalized. None of these bonds are single and double. In fact, they're all about 1.5, which is the average between the single bond that, say, this is in this resonance structure, and the double bond that it is in the other resonance structure. The average between 1 and 2 is 1.5. So if you look at the actual structure for benzene with like, I don't know, an electron microscope or something, you'll find that all the bonds are the same length, meaning there's no singles and doubles. They're all 1.5. The electrons themselves are not in one particular place. They could be distributed around the entire ring. That's what we mean by delocalized. They are not in one location. They could be in many locations, and I like to think of those electrons as smeared around the whole ring. Whereas in cyclohexene, there are no resonance structures. There are hydrogens on these two single bonded carbons. That's true here and here. There are single hydrogens here and here. There are nowhere else for these electrons to go. These are what we call localized. Very few organic chemistry teachers will call them localized, but it is the opposite of delocalized. It's in a fixed position and those 2 electrons are stuck there. So if you brought these molecules in the vicinity of, say, Br2, the Br2s are going to be less, like the electrons within the Br2 bond are going to be less repelled by these electrons because they had no fixed location in the first place. Over here, if the Br2s approached, the electrons you know are in this location, and so the electrons in the Br bond are going to be repelled away. That's the effect of London forces, and that's why cyclohexene will react with Br2. But in order for benzene to react with Br2, you need a catalyst, which lowers the activation energy. Cool? The reason benzene is less reactive than cyclohexene is because the electrons here are delocalized, so it's tougher for any particular molecule or for those electrons themselves to make an attack that will cause a reaction. Localized electrons, you know where they are, and so they can make a coordinated attack. Cool? Cool. I hope that made sense. Best of luck.